So we're going to go on and get started with this here. Now, what we're going to be looking at is more systems of equations, some with 3 variables, some with 2 variables, but these here are a little bit special in how they end up working out. I did squeeze these 2 in here so that we could get them all on the same page, but we'll need a little more room for the first one if we want to do it the way in matrices form, working it out. So the first thing we can do is convert this first matrix into our augmented matrix, or our first system into augmented matrix. So we have 1, -3, -17, -59. Our second row we have 2, or 1, -2, -12, -41. And lastly we have 0, -2, -10, and 20. Now this one here, we want to get into row epsilon form to try to get the solution. And the first thing we can do is take the negative of row 1 and add it to row 2. And this is being applied to row 2. Because we have 1 in the first place in our first row, we just need zeros below it. Now if we work this kind of off to the side, negative row 1 would be -1, 3, 17, 59. And our row 2 is 1, -2, -12, -41. And if we do add these together, -1 plus 1 is 0. 3 plus -2 is 1. -17, or 17 plus -12 is 5. 59 minus 41 is 18. Now we didn't change anything to the first row or the third row. Now the first row is fine because we do have a starting 1. The second row is now fine because we do have 0, 1. However, the third row, we need that -2 to be a 0. And hopefully we'll eventually get the third number in the second row, that's currently -10, to be a 1. Now to do this here, well, we can take 2 times row 2 and add it to row 3 and apply it to row 3. So for this one here, if we multiply row 2 by 2, 2 times 0 is going to be 0. 2 times our 1 is 2. 2 times 5 is 10. And 2 times 18 is 36. And then we add these together. Well, 0 plus 0 is 0. 0, or not 0, 2 plus -2 is 0. They cancel out. 10 plus -10 is 0. 56. So we get 0, 0, 0, 56. Any questions on this so far? Because it seems that the last equation shouldn't be like that. Would we agree with that? Having all zeros and then 56. And really what that last row is saying, if we plug in the variables, is that 0x plus 0y plus 0z is equal to 56. Or 0 is equal to 56. Is this true? No. Could that ever be true? So this is, if we ever end up getting a reduced either reduced row epsilon form or row epsilon form, where we get all zeros equals a number, it's no solution. There's no way to solve this. It wouldn't say undefined. Let's actually do that. Let me grab a note sheet. So let's plug the matrix in. So second matrix over to edit. So it's still a 3 by 4. We can say 1, negative 3, negative 17, negative 59. 1, negative 2, negative 12, negative 41, 0, negative 2, negative 10, 20. So we type the whole thing in. Second quit, second matrix, over to math. Now we can do REF, second matrix A, enter. And if we see here, we get a little bit different statement, but the last row is still 0, 0, 0, 1. We get all zeros equal 1, so it is a no solution. So it doesn't give us a domain error, it doesn't give us an error, it still finds it. Now we can go second matrix, and this time do REF, second matrix A, enter. We still get the bottom row is all zeros and a 1. So it's still, well, normally, unless it's either no solution or all real solutions. Here it's no solution because it tried to reduce it as far as it could, and it tried to get these last two, the negative 2 and 5, to be 0, but there's no way to do it. Because the only way to get the negative 2 and 5 to be 0 is if the last, or third row's third spot where z should be is 1. Because if it is 1, then we have ways to actually reduce those. Because without it, there's no way to get there without messing with the others. Mm-hmm. No, and if we did have a possibility of it being negative, we would multiply by a negative to make it positive. Yeah, we tried to keep those positive. And the reason that they got 1 for that here instead of 56 is we just multiplied this whole thing by 156, which made it 0, 0, and this is now 1. That's kind of how they got that there. Just trying to reduce it as far as they can. It's just trying to get it as simplest form as it possibly can, and it's running into an error. Any questions on this here? Solving this one. Now, before we turn it into a matrix, there's two things that I would want to do, especially if I'm doing this by hand. The first is to get rid of the decimals for this first one. And I would multiply everything by 100. And the reason I pick 100 is if we pick 10, it would only move these decimals once. So if I multiply it by 100, it moves it twice, telling me that I have 25x minus 75y is equal to 100. On the other equation, I'm going to subtract x from both sides, telling me that negative x plus 3y is equal to negative 4. So now we're trying to get the diagonal of 1s. Well, the first one we can multiply the entire first row by 1/25. Essentially divide everything by 25. because 25 divided by 25 is 1. Negative 75 divided by 25 is negative 3. And 100 divided by 25 is 4. We didn't do anything to the second row, so negative 1, 3, negative 4. Now what's kind of nice here, well, I can take row 1, add it to row 2, and apply it to row 2. Since we're just adding the 2, we don't have to do any multiplication. We can just kind of add straight down. Negative 1 plus 1 is 0. Negative 3 plus 3 is, and lastly 4 plus negative 4 is 0. That'd be tempting because again we have zeros, but what is the last equation really telling me? That 0x plus 0y is equal to 0. 0 is equal to, which is true. Now for Algebra 2, we said this is all real numbers, and we stopped there. The book kind of took it a step further, but this is what we got. Now there is a set solution for it. There are solutions that would work. But to do that, we're going to take the other equation that we have, this one here. So it tells us that x minus 3y is equal to 4. Now there's two ways we can do this, or go from here. We can solve for x, or we can solve for y. Now I'm going to do solve for x first. And what this means is that we have x minus 3y is equal to, make sure, nope, positive 4. Solve for x, I just want to get x by itself. So the first thing we can do is add 3y to both sides, telling me x is equal to 3y plus 4. Yes? Questions on this here? So what this tells us, if we solve for x, that the solution for this here is given to us by x comma, sorry, not x, because we solve for x. Whoops, not what I wanted. So, let me erase. This here, this equation here, I want the pen back. If I have a value of y, I can find the value of x, yes? So our solution set is going to be, because comma y, 3y plus 4, comma 1. In other words, any value of y that I can think of will give me a solution point. I can plug the value of y in for y, plug that same value in the other y, and go from there. And that seems a little odd, especially trying to think through that, but one of y'all give me just a value for y. Huh? 15. So we can say this is 15. In the other spot, we would say 3 times 15 plus 4. 3 times 15 is 75 plus 4 is. So that would be a solution that would work. And we could do it for any value of y. It is all real solutions that satisfy this here. Whenever we get this, when there's all zeros, it's all real solutions, but it's all real solutions defined by this here. In Algebra 2, when we got this, we just said all the real solutions and stopped. Yes, thank you. I don't know why I was thinking 25. Yeah, I was jumping ahead. 49. 30 off. Yeah, 49. That makes a little more sense. If I had plugged it in, I would have saw it. Thank you. But that is sit there. Do we kind of get this? Not so much. Hopefully that didn't confuse you too bad. So 3y plus 4. So we could solve it for x, get x, and have it in both in terms of y. We could do it also for y. This one's not as nice. Because x minus 3y equals 4. So we'd subtract x from both sides, telling us negative 3y is equal to negative x plus 4. Divide by negative 3, so y is equal to negative x plus 4 over negative 3. Now, we can make it look a little bit nicer by pulling the negative up and applying it to the top, which just tells us that we have x minus 4 over 3. But our solution for this is going to be x comma x minus 4 over 3. So in either way we write it, we either get it every single spot in terms of x, where x is the only variable, or in terms of y. If we had 3, again, we would do a similar thing, but 1 would just be the variable, so either x or y by itself, and the other 2 would be in terms of that variable. Questions on any of this here? Are you good with this here? We're ready for the next one. Solve the system with 3 variables. Now again, we've seen how to do these, especially by hand. Now we can also do them in the calculator. We can go second matrix over to edit. So the next one we're looking at is a 3 by 4. So we have 1, negative 4, 7, 14, negative 2, 9, negative 16, 1, negative 7, 13, 23. Yes. So yeah, so this, I missed the last one. Negative 31, because negative 2, 9, negative 16, negative 31. Then we'd have 1, negative 7, 13, 23. 1, negative 4, 7, 14, negative 2, 9, negative 16, negative 31, 1, negative 7, 13, 23. Now we could pick which one we want to do, RREF or REF. RREF is a little bit nicer with these here. So we get this, 1, 0, negative 1, 2. Well, calculator, 0, 1, negative 2, negative 3, and the last one is all zeros. So the fact that the last row is all zeros tells me that this is the same as last time. It's an all real solution. Now what I'm going to do is take the first 2 equations here, because we have x, y, z. So the first equation is telling me that I have x minus z is equal to 2. The second equation is telling me that I have y minus 2z is equal to negative 3. Now looking at both of these equations, well, I do notice one thing. There is a commonality with both of them. They both have a z, yes? So I'm going to solve the first one for z, or add z to both sides, giving us x is equal to z plus 2. not so much solving it, but I'm wanting to get x by itself, get x in terms of z. We can do the same thing with y. We can add 2z to both sides, telling us y is equal to 2z minus 3. So this equation is indeed all real solutions, but it's really all real solutions that satisfy this here. Now, since we got the other two in terms of z, our third spot will just be z. X is going to be defined by the equation z plus 2. And y is defined as the equation 2z minus 3. Questions on this here? And even if it did ask for, given the systems, find two real solutions that work for the system, all we've got to do is find this here and then say z is 0. Plug it into the other two. I have a solution. If I want a second one, I just pick another value for z, make it another one. And we can keep doing this as often as we want. I just keep picking values of z, plug it into the other two places, and we get our answers. Questions on any of this here? Let's look at this next one. I have a feeling for most of these, you're just going to plug them in. Now this one's a 2 by 4, 3, negative 8, 18, 15, 1, negative 3, 4, 6. Now with a 2 by 4, two equations with 3 variables, we're guaranteed to have an all real solution or no solution, because we're not going to have a single solution because we don't have enough spots. We need 3 equations to get there. Now we can do RREF again, and we get this here. 1, 0, 22, negative 3. And we can treat it the exact same way, because the first equation tells us that we have x plus 22z is equal to negative 3. Our second equation tells us that y plus 6z is equal to negative 3. For the first one, when we get it in terms of z, we have x is equal to negative 22z minus 3. And for our other equation, we get y is equal to negative 6z minus 3. Questions on any of this here? I believe that brings us to the last one, yes? All right, well, as we've done the last few, let's just go on and type it into the calculator, let it do it for us. Now this one is a 3 by 4. We get 1, 2, 3, 6, negative 1, negative 2, negative 2, negative 3, negative 6. 2, 4, 6, 12. So I can quit. So when we plug this in and do RREF, we get this matrix here. So we don't get just one row of zeros, we get 2. So it is still all real solutions that satisfy this equation. But the equation we get is x plus 2y plus 3z is equal to 6. And when the few of these that do show up on the assignment, it's going to ask for the number of solutions. It's going to say, is it no solutions, all real solutions, or a single solution? Well, we'll say all real. And it's going to ask for at least 1 or 2. It's going to ask probably at least 2 solutions. Well, so if we want a solution set that does satisfy this equation, I'm just going to start picking values for x and then y. So it's a nice value for x. Okay, so 0 plus 2y plus 3z is equal to 6. Okay, well, we need a value for y or z. What's a nice one? 10. So really we have 2 times 10 plus 3z equals 6. Now at this point we can't really pick a value for z because this still has to be true. Well, 2 times 10 is 20 plus 3z is equal to 6. Divide by 3. Z is equal to negative 14 thirds. There's one solution. Oh, I can just do it off to the side. This time I'm going to say x is 0 plus 2y plus 3 times 0 is equal to 6. I just set x and z as 0. Well, it's really just saying 2y is equal to yeah, so doing because we could have said 0 plus 2 times 0 plus 3z equals 6. I mean, there's 4 different solutions that work. And I mean, we can keep picking values of 2 of the variables, solving for the third, and find a solution that does work. So there's an infinitely many of them, but they do have to satisfy that equation. Questions on any of this here? Let's look at one more. So let's look at this here. So looking at what this says, the first row is telling me what? X is equal to 8, yes? Second equation, second row is telling me what? Y is equal to? What's Z? What is it? It's all, I mean, is there a spot for Z? So I mean, 8, negative 4, 0 would be a solution, yes? 8, negative 4 what? Yes. Yes. Uh, 3. Thousand, million, billion, trillion, quad, 78 quintillion. Is technically a solution. Yes, 78 quintillion, 654 quadrillion, 397 trillion, 685 million. That's the I'm off. So 1,000, million, so billion, trillion, quad, quin. So 78 quintillion, 654 quadrillion, 397 trillion, 685 billion, 432,198,765. Yeah. But this is technically a solution. And I did try a number like this the other day with the assignment, because I showed you that one. Because if we don't have anything representing z, it's whatever we want it to be. Yeah, I was just sitting there messing with the number key and just letting it run off. Yep. I think for one of them I tried 39 over 7, and it worked. So it's whatever we want it to be.